morning students. Today we will solve the 12th question of problem set 3. Now the question is, if the sum of first p terms of an AP is equal to sum of first q terms, then show that the sum of its first p plus q terms is 0. Here it is given that p is not equal to q. So they are two different terms. Now it is given that sum of first p terms of an AP. So it is based on the sum of terms of an AP. So sum of n terms, use this formula as n by 2 into 2a plus n minus 1 into d. This is the formula which you have to use. Now it is given that sum of first p terms. So sum of p terms will be equal to as p by 2 into 2a plus p minus 1 into d in this form. And sum of q terms will be equal to as q by 2 into 2a plus q minus 1 into d in this form. Now it is given that, see, if the sum of first p terms of an AP is equal to the sum of first q terms of an AP. That means sum of p terms is equal to sum of q terms. This is given. So according to this, when sum of p terms is equal to sum of q terms. Now sum of p terms we found out this. Sum of q terms is equal to this. That means this part is equal to this. So we can write. So therefore here p by 2 into 2a plus p minus 1 into d, this is equal to q by 2 into 2a plus q minus 1 into d in this form. Now both the sides we have got here denominator as 2. So we will multiply the equation by 2. If you multiply the equation by 2, multiply both the sides by 2. Multiply both sides by 2. So we get rid of this 2. Therefore, after multiplying, we get it in this form. P into 2a plus p minus 1 into d. That is equal to q into 2a plus q minus 1 into d. Now, this square bracket outside we have got coefficient as p, and here also we have got coefficient as q. So, we will bring this term, multiply this bracket by p and q. So, therefore here it will be this bracket. There are two terms here. Inside this bracket there are two brackets. Here also inside the bracket two terms are there. So therefore p into this will give you 2ap. Yes, then plus p into p minus 1 into d. Then this is equal to 2qa, 2aq, aq. Then plus q into q minus 1 into d. Now, this all full term, there are two terms here, we will bring it this side. So, it is 2ap, then plus, this will remain as it is, we will keep it now as it is, p minus 1 into d is, then minus this 2aq and minus q into q minus 1 into d is equal to as 0. Now, we brought all the terms this side. This is equal to 0. Now, see here, this 2ap and this 2aq. Write it together. 2ap minus 2aq. Then, solve this bracket. Now, here this and this part, we'll write it together. plus P into P minus 1 into D minus Q into Q minus 1 into D equal to 0. Now 2AP minus 2AQ. Here in these two terms, D is common here. So take out this D. And here also we can solve it together only. 2 is common. 2A is common. 2A you take out. So it will be P minus Q will remain here. Uncommon. Now plus here we will put in the bracket. Yes. Now P into P minus 1 into D. My D will take out it as common. So therefore here minus Q into Q minus 1. Here whole thing into D. D came out as common equal to as 0. Now here this round bracket and coefficient P and here Q will multiply it. So after multiplying what do we get? Here 2A into P minus Q will remain as this. Then plus here in the square bracket you see it is P square minus P. Then plus into minus is minus Q. Q square. Q into Q. Minus into minus plus Q will get. This into D is common and this is equal to 0. Now here 2A into P minus Q will remain as it is. Plus here in the square bracket you can arrange this P square minus Q square. So we get it in the form of A square minus B square equal to as A plus B into A minus B. We can factorize it. So minus P and plus Q will remain here into D equal to 0. Now 2A into P minus Q plus here this can be factorized as P plus Q into P minus Q. So here again in these two terms we can factorize it as 1 into. So minus 1 we will take out as common 1. So minus into minus is plus P here and minus into plus is minus Q here remains. This into D equal to 0. Now look at this two terms here. In this square bracket, here there are two terms inside. P minus Q is common. So bring out this also. 2A into P minus Q here as it is plus. In the bracket, P minus Q will remain. Here into P plus Q. P plus Q, this P plus Q, P minus Q is gone out. And here P minus Q gone out as common. So minus 1 into D is equal to as 0. Now look at these two. Now this whole thing is one term and this whole thing is one term. From both the terms P minus Q and P minus Q is common. So take out P minus Q as common. Then we are left with here as 2A plus in the bracket P plus Q minus 1 into D equal to 0. Equal to 0. So here after taking out common this P minus Q will take it that side. So it is equal to as this whole thing in the bracket. It is equal to 0. Put this bracket. So they are in the factor form. Now they are in the factor form. When they are in the factor form, I can take this side. So it is 2a plus p plus q minus 1 into d is equal to 0. This by p minus q. This I have brought it this side. So any number 0 divided by any number, it is equal to as 0 only. So we are left with 2a plus p plus q minus 1 into d. This is, let us take it as 0.1. Now come to the next part of the question, that is, see here. We have to show that if sum of the first p terms of an AP is equal to the sum of the q terms of an AP. So, sum of p terms is equal to sum of q terms. After solving, putting the values, we got it in this form. Next part, what is given? If we have to show that sum of its p plus q terms is 0. Now, sum of p plus q terms. Now, sum of p plus q terms in this form. Here n is equal to p plus q. So, sum of n terms formula you take, that is equal to as p plus q upon 2 n by 2 into 2a plus n minus 1. N is here p plus q. P plus q minus 1 into d equal to as 0. Now, this p plus q by 2 will take it that side. So, therefore here, now, see here, take this as 0.2. From point 1 and 2, you can observe that 0.1, 2a plus p into the bracket, p plus q minus 1 into d. And this bracket here, square bracket, is the same as this one. 0.1 this is equal to the 0.2 of the square bracket. Is same, exactly. Therefore, here in 0.1 we have got that this value equal to 0. So, therefore, we will put it as p plus q by 2 into this whole bracket, it is equal to 0. So, this we got it from 1 and 2. We got it from 1 and 2. Any number multiplied by 0 is equal to 0. So, therefore, we have got sum of p plus q terms is equal to as 0. This is what we had to prove. Therefore, sum of p plus q terms is equal to this is equal to 0. This is hence proved. Hence proved. Now let us solve for next question, that is question number 30. It is given that if m times the mth term of an AP is equal to n times the nth term, then show that m plus nth term of the AP is 0. It is just like the previous question, but the 12th question was based on sum of terms, and here it is based on the terms of an AP. So, here if we know that nth term formula is equal to as a plus n minus 1 into d. Based on this formula, see, if m times the mth term, m times the mth term is of an AP is equal to n times the nth term. This is what is given. So, then show that m plus nth term of the AP is 0. So, based on this, what is given? So, m times nth term based on this formula will be equal to as a plus m minus 1 into d. This is nth term. It is equal to as n times of nth term, that is again a plus n minus 1 into d. According to what is condition is given. Now, this whole bracket will bring it this side. So, m into a plus m minus 1 into d minus n into a plus n minus 1 into d. Into d. Whole thing like this. This is equal to now 0. Now, we'll bracket this square bracket coefficient m here. Here this square bracket coefficient n. Now, inside the square bracket there are two terms. This is one term. This is the next term. In the same manner here also we have. This is one term. This whole thing is another term. So, these two terms and these two terms will multiply by n and these two terms will multiply by n. So, we get this as am plus m into m minus 1 into d. Then, this as minus an and this as plus to minus n into n minus 1 into d equal to 0. Now here, this and these two terms will bring it together. Am minus an. Then plus m into this m into m minus 1 into d. Then minus here n into n minus 1 into d equal to 0. Now here these two terms and these two terms. There are two terms here. In these two terms a is common. So m minus n is common. Plus in these two terms here d is common. So what is uncommon? We'll put it in the square bracket. M into m minus 1 minus this n into n minus 1 into d gone out as common. Now let us multiply the brackets here. It is a plus a into m minus n. A into m minus n plus in the bracket here it is m square minus this bracket multiplied by m minus n. Here also this bracket multiplied by n. Plus to minus is minus n into n square plus to minus is minus n into 1 is n. This whole thing equal to 0. Now inside this square bracket you can see m square minus n square. We can arrange this. So other thing keep it as this. Plus here m square minus n square minus m and minus n into d equal to 0. So here this can be factorized m as we have done in the previous question. A into m minus n plus it is m square into n square will give you as m plus n into m minus n. Then minus here common one you bring, that is minus to minus plus and minus to minus plus n here. Sorry, minus to minus, this is plus n. So therefore here plus into minus into plus is minus n into d equal to 0. Now here in this bracket, square bracket, again we have got common m minus n, m minus n. So take this a into m minus n as 1, then plus into m minus n as common. Inside the square bracket we are left with m plus n. This and whole thing is gone out, minus 1 is left into d equal to 0. Now here in this both the terms we have got m minus n, m minus n. So we have here as m minus n as common into what is uncommon left, that is a plus here m plus m plus n minus 1 into d. This whole thing is left in this form. Now m minus n you take it that side. So a plus m plus n in the bracket minus 1 into d, whole thing like this way, square bracket, equal to 0 by m minus n. This I have to brought this side. So therefore here we get a plus m plus n minus 1 into d equal to as 0. As like the previous question. Take this as 0.1. Now come to the next part of the question, that is show that m plus nth term of the AP is 0. Now we go to the next part of the question, that is m plus nth term, like nth term. It is equal to as what? It is a plus m plus n minus 1 into d in this form. But here, see, look at this one. A plus m in the bracket m plus n minus 1 into d. Take this as 0.2. From 0.1 and 2, what do we have? That m plus nth term, what value? This is equal to 0.1. So from 0.1 and 2, it is well understood that m plus nth term equal to 0. This we got it from 1 and 2. See, this value is equal to 0. Therefore, instead of this, I can substitute the value as from 0.1 as 0. So, therefore, we have proved that m plus nth term of the AP is 0. Therefore, hence it is proved. M plus nth term equal to 0. Hence proved. Hence